Incidentally, in your booklet in the subjective exercises, this problem is given, but I think we went wrong with the numbers there. I think we made that 60 and 30. So to make sure that you rectify it, I am making you solve it here itself.
There are two beads are sliding.
Both the beads can slide on the triangular frame. Both the beads can smoothly slide on the triangular frame connected by a cord, light cord of length L. M is the mass of the beads. Language given by the JEE people is like this. A rigid insulating wire frame in the form of a right angle triangle ABC is set in a vertical plane as shown in the figure. Two beads of equal masses M each and carrying Q1 and Q2 charges are connected by a cord of length L and can slide without friction on the wires. Considering the case when the beads are stationary, determine alpha, T and N. You will have a normal force like this, mg is like this, T minus Fe is like this. Why? Fe will be radially outwards, both are like charges. Now equate these forces along this one and perpendicular. Simple logic. I will redraw the diagram. This is 30 degree. On Q1 you are taking normal force N1 this way, mg this way, and T minus Fe this way. This angle is alpha. So this will be T minus Fe cos alpha. This will be mg sin 30. Tension in the cord minus Fe, because Fe will be outwards. I took it in the opposite direction. So equate this to this. Similarly equate normal force to mg, this will be 30, right? mg cos 30 plus T minus Fe sin alpha. Say something. T minus Fe sin alpha. That's it. Equate this to this, equate this to this to equal to n. You get all the answers. Simple adjustment, but the why I have discussed it is in our booklet we have given the diagram slightly deceptive. We have made it this way. So it becomes a little bit complicated for the child to visualize it. Or probably we gave 60 and 30 in the reverse. We have rectified it. I assume we have rectified it. Let's see.
Excuse me, sir. Sir, can you please repeat the question? Actually, the VC was it was not on.
There are two beads with charges M1, which charges Q1 and Q2, but of the same mass, which can slide on this rim of a triangle, of right angle triangle ABC. 30, 60 is given, and this is a light cord. The cord doesn't have any mass. They are connected by that. Right? If the system is in equilibrium, he says the wire is smooth, there is no friction. Find alpha when the beads are stationary. That means the system is in equilibrium. So if it is in equilibrium, I just equated the forces. Fe will be in this direction, so T minus Fe will be in this direction, because T will be this way, Fe will be outwards. So I have three forces, 1, 2 and 3. Now this I resolved along this direction, mg along this direction. Second, perpendicular to the inclined plane, I equated the forces.
Thank you, sir.
Obviously you know what is to be done on the other side for this. The same logic. T minus Fe will be this way. Mg will be like this. This will be N2. Now he will ask you for the N2 of the other one also. Normal reaction for both the beads. The same logic. Forces up the inclined plane should be equal to forces down the inclined plane. One of the subjective problems in your booklet. Stop me half an hour before. I'll take your doubts in HCV. One problem from HCV which all of you will have if there's a doubt is the integration of a thin rod with charge Q. If this is of length L, we dealt with this for infinite length, right? If this is of length L, then how do we do it? Consider an element dy such that if this is at a distance of d, this is y, and this angle is alpha, this angle is beta. The topmost point will subtend an angle alpha, lowermost point will take this also to be alpha because right now it is a perpendicular bisector. Right? It is a perpendicular bisector here. If this distance is y, the integration is slightly tricky, have a look at it. Now because of this element, this will be d, it will have a horizontal and vertical component. Right? If I take this angle to be theta, this angle will be theta, this will be dE cos theta. Agreed? For every element here, there will be an element here which will give me a dE whose vertical component will cancel out with this. So all I will have to do is to integrate dE cos theta. 2 times dE cos theta. Lower element also added up. Or remove 2 and keep this as it is. So that I will take the limits from the lower to the upper. Minus alpha to alpha. By the way, what will be the value of dE? K dq by that distance whole square. Y square plus d square whole square. This distance will be under root y square plus d square. Square of that. Now you will get k lambda dy by y square plus d square. Cos theta is d under root y square plus d square. K lambda integral d dy by y square plus d square to the power 3 by 2. Now technically to integrate this, I will bring it in terms of theta. Only then your integration will be safe. If not, you will be stuck up badly with the limits. Limits will be the havoc for you. To avoid that limits, what do? We will take tan theta. Tan theta is y by d. Implies y is equal to d tan theta. dy is equal to d secant square theta. Now your integration is k lambda. Dy is d secant square theta d theta upon denominator. Have a look at it. Y I will take as d tan theta. D square tan square theta plus d square will be d square secant square theta. Whole to the power 3 by 2 is d cube secant cube theta. D cube secant cube theta. This is k lambda by d integral d numerator d square, denominator d cube. Right? Secant square theta, secant cube theta will be 1 by secant theta. That will become cos theta d theta. Least value of theta is minus alpha. Suppose by chance they are not of the same angles, what will you do? You will put this as beta and alpha. But here I will put minus alpha and alpha. Because why? I will take the same angle, so that for every element here I can be damn sure that there is an element which will cancel out the vertical components. If not, I will have to calculate even the vertical component. Right? So now this will be k lambda by d. Integral cos theta sin alpha minus of sin minus alpha is now if he tells you that the wire is of infinite length, what will you do? You will put alpha equal to 90, alpha equal to 90. Sin 90 is 1 plus 1?
2.
2k lambda by d. Did you get your answer? One second. In your booklet, this is a problem from HCV where he gave you length L and perpendicular bisector. In your booklet, what we people did is, we gave only this and we said at an angle of finite wire we have given. So this angle is given. I am interested in the field here. Right? Clear? Now watch out for this. Okay, let me do it. Instead of telling you the answer, I do it. Take it down to you. You will have trouble with that integration because integration is not yet done. The concept is the same for infinite long wire. Playing with the limits is difficult. Here if you take the limits for y, it will be very messy for you. Convert it in terms of theta. How will we get to know this idea? By default you will know once integration is done. You will know what you should have to select so that integration is becoming easy. Yeah, you know.
So can you explain how did you get the denominator in the second? Yeah.
Y is equal to d tan theta. D square tan square theta plus d square is d square secant square theta to the power 3 by 2. D cube secant cube. Suppose I don't have the lower part. Then what will happen? So same derivation, right? This angle is alpha. I take a small element dy at a distance of y. Right? This angle is theta. I will have dE and I will have dE cos theta and I will have dE sin theta. Now in the booklet we gave you this question. HCV's question was symmetric on both sides. In the booklet what did we do? We took a finite wire of some certain length and we removed the lower part. So once again the students have a trouble understanding the integration. Now I have already done this integration, right? This integration is the integration of dA cos theta. So iska answer I can directly tell you k lambda by d integral cos theta d theta 0 to alpha. Here I am safe. Right? This will be k lambda by d sin alpha. Now this will be, I will have to integrate this. Will you people try or should I do it? Right. Same substitution. Tan theta is equal to y by d. Y is equal to d tan theta. This will be k lambda dy by that distance whole square. D square plus y square. Sin theta will be y divided by root over of d square plus y square. Integrate this once again from the limits 0 to alpha. Integrate and tell me the answer. You will be amused to see the answer. It will be same as that of horizontal component.
You have to use the same substitution.
No, I want to bring it in terms of theta because my limits are comfortable in theta. If you integrate directly y dy and put limits 0 to infinity, I am okay with it. But here, whole of your game of integration is you are having a trouble with the limits. This is a finite length. Hence, bring it in terms of theta. You have no choice. Maximum value of theta is alpha. Lower limit is 0. So, always bring it in terms of theta. Tell me what is the answer you are getting. K lambda by d sin alpha is what you will get. If I remember well. Sir, try the problem. I will not do the integration. I have done the horizontal integration. Now do the vertical integration.
I got a little confused. I'm analyzing it.
Here, because it is a semi-finite wire, the lower element will not get cancelled out. I will be left with the dA sin theta. Integrate that, you will get k lambda by d cos alpha. Now when he gives you a finite wire, if he gives you this particular angle, you will be able to solve. In the booklet, 99% of the people bring this as a doubt. We gave you this angle, 30. They will substitute 30 and come and say they didn't get the answer. This angle is given as 30. What will alpha be? 60. Right?
Minus cos theta.
Okay, so what are you getting?
Minus
The mind.
Why will you get a minus sign.
So because when you integrate sine
It comes out to be tan theta by sec theta.
yeah, sine
So how will you interpret this negative sign? Does that mean field is upwards? No, no, yaar.
positive.
You have taken it downwards only. No. See. This is theta. This is d sin theta. All of you are getting a negative sign.
Yes, sir.
What value?
Then 1 minus cos alpha.
Pardon?
1 minus cos alpha. Cos, right. Integration 0 to alpha na.
1 minus cos alpha, right? Then your problem is solved.
1 minus cos alpha. Right. 1 minus cos alpha.
1 minus cos alpha, your problem will be solved.
Cos 0 1.
Cos 0 is 1, no yaar, it's not 0. Perfect. Because you should get positive value. Negative value you will not be able to interpret. Negative value means I'll have to take it in the upward direction.
Direction will be same.
Now listen. Something important is being covered, you will have to concentrate on this. Partly we will use some part of mathematics to visualize this. Firstly, the subtopic's name is Gauss law. We will use a mathematical simile here. This distance is L, this is theta. Sector formula tells me theta is equal to L by R. First step. Are we all okay with this?
Yes, sir.
Sector formula tells me theta is equal to L by R. Please pay attention here. Thane, settle down. Thane, settle down. AC is not working in your room, is it? Settle down. Okay. Now, this length of the arc, whichever small length that you are taking, R should be perpendicular to L, then you can use the sector formula theta equal to L by R. Yes or no? We take this one more step ahead. If it is a circle at the center, theta is equal to L by R, L is 2 pi R by R, I get 2 pi. What is the big deal? Angle subtended by the circular arc at the center is 2 pi. We take this one more step ahead. Angle subtended by a circle, anywhere inside will be 2 pi. Angle subtended by a circle, anywhere inside is 2 pi. Why will that be so? Keeping this as the center, draw a circle. Keeping this as the center, draw a circle. Right? Now this and this will subtend the same angle here. This and this will subtend the same angle here. Sum of this will be 2 pi. Is the logic clear? We extrapolate this concept one more step ahead. Any irregular closed loop angle subtended inside will be 2 pi. How will you do that? Extend this way and draw a circle with this as the center. Now, don't you think this and this will subtend the same angle here? Similarly, this and this will subtend the same angle. Every small element I take and substitute, will I get the total angle to be 2 pi? You are concluding on something which is very trivial. Any closed loop subtends an angle of 2 pi anywhere inside the loop. Agreed? We actually don't need this. We need for a surface. But to extrapolate this concept, we are doing it from a line. Take this down, we'll deal with the surface. We'll introduce solid angle. Now listen, theta is L by R is a sector formula. Please pay attention here. You are going to learn something new in electrostatics today. Visualization of this will be difficult because we will be dealing with 3D. I repeat once again, all of you hold, listen. Theta is L by R, something that you people know. If it is a closed circle, angle subtended at the center will be 2 pi, something that you people know. What we are telling you right now is, even if the point is not at the center, anywhere other than the center also the closed loop will subtend an angle of 2 pi. The closed loop will subtend an angle of 2 pi. Now what if it is not a circle, it is any closed loop. Any closed loop will subtend an angle of 2 pi anywhere inside. Why? Keeping this as the point, draw a circle. This element and this element will subtend the same angle. This element will subtend the same angle. That way if you continue, every element will subtend the same angle inside. Sum of that will become 2 pi. Take it down, I will introduce solid angle, 3-dimensional angle. Now this is a line, circle. What if it is a sphere?
Sir, in that
Now we introduce solid angle. How do you want me to visualize solid angle? This is a solid angle inside. See in the camera. This is the solid angle inside. Are you able to visualize the solid angle? Right? This is the solid angle inside. What will be the linear angle? If I press this up, this will be the linear angle. This will be the solid angle. Are you able to visualize this? This area, my hand, which will subtend an angle inside, that will be the solid angle. Fine. Now have a look at this. If you are showing me a solid angle this way, this will be the area delta S. I will show solid angle by this omega R. Solid angle is represented by this symbol delta S by R square. See the dimensions. L by R has become area by R square. We are playing with the dimensions. Now we have a small issue here. Till yesterday you never told us that area was a vector quantity. Till yesterday area was a scalar for you. Today you have made the area vector quantity. Yes, we have made it a vector quantity. Is it to your convenience that whenever you want it to be a vector, you will make it a vector? Whenever you want it to be a scalar, you will make it a scalar? Yes. Whenever we want it to make it a vector, we will make it a vector. Why? There is a reason for it. Till now for you, area of a rectangle was only one, length into breadth. Now for me it is two different surfaces. How do I know whether I am length, magnitude is the same? Am I talking about this surface or am I talking about this surface? Should be clear to the student. So how do I tell you the vector direction? If I am talking about this surface, I will tell you the area vector is perpendicular to the surface outwards. If I am talking about this surface, area vector is perpendicular to the surface outwards. So when I am seeing from your side, this will be the positive x-axis. How do I represent this area? Length into breadth I cap. How do I represent this area? Length into breadth minus I cap. So which surface, which side of the surface are you representing also will be clear. Only if I make the area a vector quantity. Hence we made the area a vector quantity. Are you getting this point? Now this particular area is a vector. I am taking the outer surface. If I keep my hand this way, this side the area vector will be like this. This side the area vector will be like this. Are you clear about it? Now using the same logic, if I take a sphere, what will be the angle subtended here? Solid angle subtended here is 4 pi r square upon r square will be 4 pi. So if you take a closed sphere, angle subtended inside is 4 pi. Can you extrapolate that concept to the same logic here? Yes. If I take a sphere, anywhere inside angle subtended is 4 pi. The same logic we extrapolated from linear angle. And then any closed surface, the angle subtended inside will be 4 pi. Any closed surface, the angle subtended is 4 pi. Angle subtended anywhere inside anywhere inside is 4 pi. This information from mathematics we are using in Gauss law. Only then we will be able to prove Gauss law. Now you will start getting an idea where from did you get 1 by 4 pi epsilon naught. K value is 1 by 4 pi epsilon naught. 4 pi why? Because of this you are getting 4 pi. Take it down till here. We define a new quantity called flux with the symbol phi, which will be E dot A. Area you made a vector today. So dot product of two vectors will be a scalar. So flux is a scalar, first point. Measured in Newton meter square per coulomb. Field is Newton per coulomb. Field is Newton per coulomb meter square. So flux is a scalar quantity. What does it generally measure? It measures the number of electric lines of force intercepting a surface perpendicularly. Number of electric lines of force intercepting a surface perpendicularly. Right? So tomorrow if you take a surface like this and tell me this is the area vector and you have a field this way, then the flux through this surface EA cos 0. Right? Dot product, either you resolve one towards the other or the other towards the first. You can also take such type of inclined planes. If the field is P, Q, R, S and the field is this way, flux through P, Q, R, S will be E into area of P, Q, R, S into cos theta. So if you see the inclined plane like this, this is the field, this will be the area vector. If this is theta, this will be the field, this will be 90 minus theta, am I right? So this will be cos 90 minus theta. E into area of PQRS, you will get this area of PQRS. Instead of this into this, you can write area of POLS. Area of POLS. Right? Understood this? It's like telling you this is the area, this is the field. Either you resolve the field this way or you resolve the area this way. This is the area, this is the field. Either you resolve area vector will be perpendicular to it. Either you resolve the field along the area or the area along the field. Clear? A dot B is equal to AB cos theta. Either resolve A along B and multiply or resolve B along A and multiply. Is that clear? Basically, you are defining a new physical quantity called electric flux. Number of electric lines of force intercepting a surface perpendicularly is the raw measure of electric flux. But it is a raw measure. Quick. Now listen to the origin of Gauss law. Settle down. Thane, settle down. Thane students for some reason are very disturbed. Could you switch on the mic there?
Yes, sir.
What is the problem?
Sir, there is unrest because both the ACs are not working and
थाने फोन करो तुरंत वो सेट करवाओ यार बच्चे they are feeling very restless अभी चाहिए तो 15 मिनट ब्रेक देंगे वो एसी वाले को आने के लिए बोलो listen now firstly you are defining the flux. Thane students, don't worry, sweat will be the secret behind your success. I'm not joking, right? Settle down, listen. The concept is very important, please concentrate on this. I have an area vector delta S. I have a charge q placed here. I have a charge q placed here. This distance is r. What will be the flux through this particular surface? Flux is phi. Flux through a small surface will be d phi. the flux will be E dot ds. According to the science that we have learnt till now, field will be directly proportional to 1 by r square, area will be directly proportional to solid angle into r square. Right? That means this will remain constant. R square will get cancelled out. The flux through this surface will be constant, provided the solid angle remains the same. What do you mean by that? Tomorrow I have a charge Q here, I have delta S1 here and delta S2 here. Now flux through delta S1 will be equal to flux through delta S2. Till when both of them are subtending the same solid angle, flux through both the surfaces will be the same. How is that magic happening? Flux is E dot ds. As I am moving away, undoubtedly R is increasing. But it is independent of R. Field will be decreasing by 1 by r square, area will be increasing by r square. So the product will remain constant. One more significance here. You may say that for both these surfaces you could tell me that the flux is the same because area is increasing and field is decreasing by the same ratio. What if I just incline this area this way? This is delta S1, this is delta S2. This is the solid angle.
We have to resolve it.
Right. Undoubtedly area increased but field did not change. But we are yet safe because now theta will take care of it. Flux through delta S1 will be equal to E dot ds1. This is 1 by r square solid angle into r square. Rather, solid angle subtended will be the same. Flux through delta S2 will be E ds2 cos theta. This will be E ds1 cos 0. ds2 cos theta will be equal to ds1. Hence, if two surfaces subtend the same solid angle at a point charge, flux through both the surfaces will be the same. I repeat, please pay attention here. If two surfaces subtend the same solid angle at a point charge, then the flux through both the surfaces will be the same. Is it logical to you? Then Gauss said, a closed surface angle subtended is always 4 pi. So flux through a closed surface should always be wonderful, right? He calculated that flux and he said this is Gauss law. If two surfaces subtend the same solid angle, the flux through both the surfaces will be the same. May it be this way or may it be this way. Till when they subtend the same solid angle, the flux through both of them will be the same. For a closed surface, solid angle subtended anywhere inside is 4 pi. So flux through a closed surface should remain. He calculated this flux and told us that this is Gauss law. Take it down, we will calculate this flux. So we understood one thing for sure. If two surfaces subtend the same solid angle at a point charge, the flux through both the surfaces will be the same. Yes or no? Now Gauss said, consider a surface like this with a charge q here. He took this particular area, he called this ds. The field will be this way. That area will subtend an angle here. This angle is called d omega. This angle is theta. Angle between field and ds is theta. The area subtends an angle of d omega at the point charge. The area subtends an angle of d omega at the point charge. Flux through this particular surface is E dot ds. This distance is taken as r. kq by r square ds cos theta. Cos theta, E and ds have an angle. Right? d phi will be kq by 1 ds cos theta by r square. ds cos theta by r square. This will be ds cos theta by r square will be d omega. Whenever you tell me a solid angle this way, If this is area delta S, this is the solid angle and R. Solid angle is delta S by R square. If by chance this area is not perpendicular to the R vector, then resolve it. The area should be perpendicular to the radius vector. If it is not perpendicular, then ds cos theta divided by R square will be the solid angle. So now this will be ds cos theta, this projection, by R square, that will be the solid angle. Integral d phi is q by 4 pi epsilon naught closed integral d omega. ds cos theta by R square is d omega. Why are you giving me the integral, closed integral? I am considering a closed surface area. For a closed surface area, this is q by 4 pi epsilon naught. Closed surface area will always subtend an angle of
POWAI.
It turns out to be q by epsilon naught. Q is the net total charge enclosed inside. If this turns out to be true, this is the way you write Gauss law. Closed integral E dot ds will be q net enclosed by epsilon naught. Closed integral E dot ds will be the flux through this surface. Why are you using this symbol closed integral? You have to use it because only for a closed surface area this will turn out to be 4 pi. And hence it turns out to be q net enclosed by epsilon naught. Q net enclosed by epsilon naught. Lot of interpretation to be done for this. Take this down. This is the proof for Gauss law.
Sir,
Yeah.
sir, can you please explain the diagram like how it is?
You have a charge q here and you have taken an arbitrary surface. One small area ds is this. ds vector will be perpendicular to the area, field will be this way. Flux through this surface will be E dot ds. E will be kq by r square ds cos theta because of the dot product. ds cos theta by r square is the solid angle d omega. Closed integral of d omega will be 4 pi.
Sir, will you explain again, sir?
I have taken an arbitrary surface, closed surface. One small area that I have taken, I am calculating the flux through that particular area. The area vector is dl this way, E is this way. Flux will through this area will be E dot ds, E ds cos theta. What is the field here? kq by r square. ds cos theta by r square. If this is ds, this will be ds cos theta. By r square will be this solid angle. Closed integral of this solid angle will be 4 pi. Any closed surface will subtend an angle of 4 pi anywhere inside. Now listen to the interpretation of Gauss law. Please pay attention here. Something important is being covered. You have a charge q1 here, minus q2 here and q3 here. I assumed a Gaussian surface like this. Gaussian surface. ये काहे का surface है यार? Where from did you get this Gaussian surface? It's an imaginary surface visualized by us. How the hell do you want me to visualize surfaces? Rules will be told to you. NASIK, what happened? NASIK, are you people able to see the board? Okay, right. Now, who assumed this Gaussian surface? I assumed this Gaussian surface. Do you mean to say you have a liberty to assume a Gaussian surface? Yes, it's your liberty. Will we be told the rules to assume Gaussian surface? They will be told. They will not be rules, they will be suggestions. Can I think of any such arbitrary Gaussian surface? Yes, because whatever the surface may be, the angle subtended anywhere inside will be the same. So, closed integral E dot ds, the flux through this surface will be q1 minus q2 by epsilon naught. What did you do to q3? This should be the charge enclosed inside the Gaussian surface. Are you trying to tell me flux through this surface due to q3 will be 0? Yes. Why? If I have a closed surface and I have got this charge, the lines of force entering in will be leaving out. Here ds is like this, field is like this. Here field is like this, ds is like this. All throughout the right part of it I will get positive flux. All throughout the left part of it I will get negative flux. E and ds are opposite. They cancel out. So flux through this will be 0. If I have a charge outside the Gaussian surface, flux through that surface because of this charge will be 0. But what makes your apprehension very positive here is that field is due to all the charges. Due to all the charges within the vicinity. Within the vicinity. That makes me a bit uncomfortable. Yahan field you are telling me is because of Q1 minus Q2 and Q3, yes. But flux will be only because of Q1 and minus Q2. We will prove that also. Don't worry about it. But right now, justification of Gauss law. I have a charge Q at a distance of R. How do I calculate the flux and the field? I will assume a Gaussian surface such that the charge Q is at the center. I assumed, mind my language, I assumed. That means tomorrow you will also have to assume a Gaussian surface, yes. Will that be my responsibility to assume the surface, or will the paper setter give me that Gaussian surface? It will be your responsibility to assume the Gaussian surface. I want the field at a distance of R. The field will be this way, this will be ds. Closed integral E dot ds will be equal to Q by epsilon. Closed integral E dot ds will be equal to Q by epsilon naught. All throughout the surface E and ds are parallel. E closed integral ds cos 0 is Q by epsilon naught. E 4 pi r square will be Q by epsilon naught. E is equal to 1 by 4 by epsilon naught Q by r square. Now, if you people observe carefully, I have made a fool out of you. Could you switch off the mic, please? If you people observe carefully, I have made a fool out of you. I proved Gauss law from Coulomb's law. I did the reverse calculation. So why the hell did you do that? I didn't give you a proof for Coulomb's law. I have not. I have shown to you how to assume this Gaussian surface so that I can calculate the field. What do you mean? If by chance I would have assumed a Gaussian surface such that charge is not at the center, then my problem will be E ds here will be okay, E ds here will not be okay, here E and ds will be having different angles, and I don't know the angle between E and ds all throughout the surface. That too the surface is varying. That too the angle is varying. Right? Hence, is this true that E dot ds will be equal to Q by epsilon naught? Yes, absolutely that will be true. Can I proceed further to simplify that? I cannot proceed further to simplify that because magnitude of the field is not constant all throughout this surface. I cannot bring it out of the integral. Above all, I don't know the angle between E and ds, it is continuously varying. So integral E dot ds is Q by epsilon naught will be 100% varied. It is a universal law. But I cannot use it to go ahead with the calculation of the magnitude of the field in this case. Hence, assuming the Gaussian surface needs a knack and art. There are a few suggestions for that which will be told to you. What are they? First, assume a surface whose area is known. I cannot assume a surface like this. Undoubtedly again integral E dot ds is equal to Q by epsilon naught. I cannot proceed further here. I don't know this area. Surface integrals are not yet taught to you. Right? But then, if I assume a surface area whose area is known, then I can put integral ds as 4 pi r square or that area known. Second, I assumed the Gaussian surface in such a way such that the magnitude of the field was constant. That's why I could bring it out of the integral. Third, I knew the angle between E and ds, only then I can go about with it. Here if I don't know the angle between E and ds, I cannot go about with it. Hence, all three rules should be obeyed as far as Gauss law is concerned. They are suggestions. Assume a Gaussian surface whose area is known. where the magnitude of field is constant and I know the angle between E and ds. Same sphere I consider here, I will be helpless if the charge is not at the center. Right? I will dictate these rules, take it down till here. Somebody switched on the mic in between. Who was that?
Sir, I want out, sir. If the Q is placed outside the surface, why its flux will be zero?
Angles subtended by a closed surface anywhere outside is 0. Anywhere inside is 4 pi. Angle subtended by a closed surface anywhere outside will be 0. Anywhere inside is 4 pi.
Sir, how anywhere outside?
Pardon?
Sir, why would the solid angle be zero anywhere outside?
Here you will have to visualize solid angle for that. It is a 3D diagram. Do one thing, put it on Google, you will get this diagram, you will be able to visualize that. Angle subtended by any closed surface anywhere inside is 4 pi, anywhere outside is 0. Remember that. You can see that on the Googles, any of the maps, any of these diagrams, they will show you the 3D diagrams for this. In a simple language, I will tell you, the left part of it will give me negative flux, right part of it will give me positive flux. A much more crude way of explaining is, total number of lines entering in will be equal to total number of lines going out. Hence the flux through a closed surface for charge outside is 0. If one of you changed your mind and you assumed a Gaussian surface like this, then closed integral E dot ds will be equal to Q1 minus Q2 plus Q3 by epsilon naught. Is that clear? One of our friend was feeling very bad for this Q3. He wanted that Q3 to be accommodated inside. One second, wait. I have got a charge Q here and the flux and the closed surface. The flux through this surface because of this will be 0. Why? Here E and ds are opposite. So whole of the left part of it will be negative flux. Whole of the right part of it will be positive flux. It will become 0. Yeah. Somebody switch on the mic.
Sir, in the first case when you do Q1, Q2 inside the Gaussian surface, I didn't understood why the flux will be Q1 minus Q2 upon epsilon naught.
That is Gauss law here, net total, closed integral E dot ds. We derived Gauss law, Q net enclosed by epsilon naught. What is the net enclosed inside the Gaussian surface? Q1 and minus Q2. Whatever is the net total charge inside the Gaussian surface, you will take it here by epsilon naught. Can I rub the right hand side part of the board? Now you said something very dicey in this situation. First of all, write down the suggestions to assume Gaussian surface. Suggestions to assume Gaussian surface. First suggestion. First suggestion. Assume a Gaussian surface whose area is known. Assume a Gaussian surface whose area is known. Second point. Magnitude of the field should be constant. Magnitude of the field should be constant. All throughout the surface. Magnitude of field should be constant all throughout the surface. Third point, angle between E and DS must be known. Angle between E and DS must be known. Angle between E and DS must be known. In the bracket, preferably 0 or 90. Preferably 0 or 90. Preferably 0 or 90. Now listen, these are suggestions, not rules. You need not follow this rule, yet Gauss law will be applicable. You may not be use Gauss law to further simplify and find out field, but Gauss law will be applicable. Right? Second, if you people observe carefully, I told you closed integral E dot ds is equal to Q net enclosed by epsilon naught, but field is due to all charges within the vicinity, due to all the charges within the vicinity. Now have a look out for this logic. I have charge Q here, Q1 here. I assumed a Gaussian surface this way at a distance of R. Now you tell me closed integral E dot ds is equal to Q by epsilon naught. This charge must be the charge enclosed inside the Gaussian surface. So it should be Q. You told me this will not change. Then E integral ds cos 0 is Q by epsilon naught. E into 4 pi r square is Q by epsilon naught. E is equal to 1 by 4 pi epsilon naught Q by r square. Something fishy? You are getting the field only because of this Q, but you have told me field is because of all the charges within the vicinity. We have gone wrong here. Field here will be because of both. ds will be like this, field will be like this. Here field and ds will be like this. Incidentally, this will be correct. I cannot proceed further. Magnitude of field is not the same all throughout this. Bringing it out doesn't make sense. Cos 0 also doesn't make sense. Field because of this and this. Here will be this way. Because of this will be this way. Resultant field will come like this. Resultant field. And this will be ds. Agreed? Hence, field will be because of all the charges within the vicinity. This will be universally right. I may not go ahead with the simplification. Simply because field will be because of all the charges within the vicinity. Are you clear with this point? Second most important point. Suppose I go inside the atomic structure. Your chemistry people in the starting of atomic physics destroyed our comfort zone of an orbit. They removed the orbit and they told you hereafter you will have an orbital. And what is orbital? Probability of finding the electron in that orbital will be. Right? Now if I assume a Gaussian surface like this, I am in soup. I don't know if that electron is inside or outside. Closed integral E dot ds will be equal to Q by epsilon naught. Now Gauss law will become a sense of probability. Hence, only Matveev specifies this. He says E macro. Gauss law is a macroscopic viewpoint. You can never ever tell me if an electron is inside or outside. Probability will come into picture. Uncertainty picture will destroy your ability to tell us the position. Hence, E macro dot ds is Q by epsilon naught. It is macroscopic viewpoint. Don't tell me what if the Gauss law Gaussian surface is passing through an electron. Should I take the electron inside or outside? Not permitted. Macroscopic viewpoint. For me the electron will either be inside or outside the Gaussian surface. Is this clear? All of you. Quick. You're able to see. Now listen. The way we introduced, please listen to the logic. Textbooks don't describe all this. The way we introduce the topic, quite a few of you will be tempted to say that a symmetric spherical structure is the only Gaussian surface I can think of. No. For instance, an infinite long wire, positively charged infinite long wire. Do you people remember the field at a distance of r? How much? Now if I assume a Gaussian surface like this, I am in trouble. Field will be radially outwards, ds will be this way. Field will be radially outwards, ds will be this way. Now r also will be changing. Magnitude of field is not the constant all throughout. Angle between E and ds is changing. So a spherical Gaussian surface for this type of a structure will be suicidal. Then cuboid also will not help you because the cylindrical structure is the only structure which will be symmetric because the field is radially outwards. If the field is radially outwards, I'll assume a Gaussian surface of length L, cylindrical. Pay proper attention to this. You are supposed to get it out after I finish this problem. This will be E, this will be ds1, this will be E, this will be ds2, this will be E and this will be ds3. Agreed? So closed integral E dot ds should be equal to Q by epsilon naught. This will be lambda L by epsilon naught. Lambda is the charge per unit length. What is the charge enclosed inside? Lambda L will be the charge enclosed inside. This will be E dot ds1 plus E dot ds2 plus E dot ds3 will be equal to lambda L by epsilon naught. Yes or no?
Yes, sir.
E dot ds1 will be 0. Why? E dot ds3 will be 0. E integral ds2 cos 0 is lambda L by epsilon naught. 2 pi RL is equal to lambda L by epsilon naught. E is equal to 2k lambda by R. Listen, I have proved my point. What was your point? Hey, KHARGHAR फिर से गायब हो गया यार. Something very important is being covered. हो क्या? KHARGHAR. Take this down, I'll explain. KHARGHAR will join us by then. पूरा का. When you integrated, when you did this, you integrated from minus to plus.
So I can't be taken infinitely.
Currently I cannot, then the right hand side q will be infinite.
You would have to cancel those x1 and x3.
Infinite. Lambda L will be infinite. KHARGHAR. KHARGHAR, are you back? Wonderful. Now listen. We have done this using integral E dot is Q by epsilon naught. Q net, what did you tell me? 1 second, all of you pay attention. You told me Q on the right hand side here should be the net charge enclosed inside the Gaussian surface. You took that. But you got the field because of all of the way. Field because of all the charges within the vicinity. Field because of all the charges within the vicinity. How do you justify that? When you did this using calculus, you integrated from minus to plus infinity. Only then you got 2k lambda by r. Somewhere in the derivation you have concealed the fact that the wire is of infinite length. Because if I turn this wire here, even then I get the same answer. So there is a mistake if I turn the wire. Implies somewhere in the derivation you have concealed the information that the wire is of Infinite length. Where did you conceal this information? Louder. Wonderful. Have a look at it. Irrespective of this length, you took the magnitude of field same from here till here. Not only that, you took E and DS2 parallel all throughout. That's possible only if the wire is up. If I take a semi-infinite wire, just for your information, you know this will be K lambda by D and K lambda by D. Yes or no? So if I assume a Gaussian surface cylinder like this, the field will be slowly changing its direction. Angle between E and DS will not be the same. Will not be zero. It will be changing. Are you trying to tell me that you cannot use Gaussian cylinder to calculate the field for a semi-infinite wire? Yes. Not only that, even for a finite wire I cannot. If it is a finite wire, I take a Gaussian cylinder this way. Here the field and here the field will not be parallel. Finite wire, it will keep changing this way. So I don't know the angle between E and DS. Not only that, in this case, the magnitude of this field I could bring it out of the integral. Why? Because the magnitude is constant. When will that happen? Only if the wire is up. I have proved 2 points here.
Sir, sir, our VC was interrupted now, so can you explain from where the derivation is wrong?
Derivation is not wrong, it is 100% right. Did you come till here?
No, sir, you said that we have concealed the information of infinite.
Right. Somewhere we have concealed the information that the wire is of infinite length. Right. Where did we conceal that information in the derivation? Here we have concealed the information. I bought the magnitude of the field outside. That will be possible only if the wire is of infinite length. If it were of finite length, say even a semi-infinite length, the direction of the magnitude of the field is changing this way. Right. Angle between E and DS is changing. I have taken angle between E and DS to be constant all throughout the surface, independent of this value of L. Angle between E and DS is varying. If it is a finite wire, if it is an infinite wire, angle between E and DS will remain 0. Above all, magnitude of the field can be brought out only because the wire is of infinite length. Wire of infinite length.
Sir, sir, there's a problem with the THANE receiver. So do you mind kindly explaining it once again, the entire derivation?
Take it down and
Please.
explain. Take it down and explain.
Thank you, sir.
What will be the issue with the cube?
Listen, all of you concentrate on it. I repeat, here I cannot assume a spherical Gaussian surface. If I assume angle between E and DS will be varying, so you assumed a cylindrical Gaussian surface of length L. Closed integral E dot ds will be q net, that will be lambda L by epsilon naught. This will be E dot ds1, E dot ds2, E dot ds3. These both became 0 as they are perpendicular. I am left with this. You are assuming the magnitude of field to be the same all throughout this length and angle between them is 0. That happens only if the wire is of infinite length. This is what I was explaining. If the wire is of finite length, only at the center the field will be this way. Slightly above, if I take a Gaussian surface like this, slightly above the field and slightly below, the field will not be radially outwards. Below the field will be this way, above the field will be this way. The angle between E and DS along the length will be changing if the wire is of finite length. So where in the diagram did you conceal the fact that the wire is of infinite length? You have concealed it here. You took the magnitude of field to be the same all throughout this length. You took the angle between E and DS to be the same. You took the angle between E and DS to be the same. E ds2 is equal to lambda L by epsilon naught. Right? On simplifying, you realize that you are getting the field because of an infinite long wire. Right? Because of an infinite long wire. Why are you? You did this integration from minus to plus infinity. You did this integration from minus to plus infinity. Then you got 2k lambda by r. Here you are getting for the infinite long wire because you assumed the field to be same all throughout. Because you assumed the field to be same all throughout. E ds2 cos 0. 0 is the angle between E and ds. If you take a finite length, angle between E and ds will not be the same. Clear with that? Angle between E and ds will not be the same. Are you clear with that? All of you? Quick. In all the problems that will be given to you, surface integrals are beyond your scope. Surface integrals are beyond your scope. Hence, you will always have to think of an indirect means of using Gauss law to solve such type of problems. What do you mean by that? They'll give you a surface like this. This is Q, this is A by 2 and this is A. They'll ask you what is the flux through this particular surface. They'll ask you what is the flux through this particular surface. Right? Traditionally, what am I supposed to do? I'll have to take this particular strip. I have a charge Q here. I will have to take a particular strip here. E dot ds. E dot ds need to be integrated from here till here. That flux need to be integrated from here till here. 2 times you will have to integrate. Surface integrals, line integral will be this. Surface integral will be this, volume integral will be this. Right? You take a small element here, you have a charge Q, you will take the flux all throughout this particular length. That you will have to integrate from here till here to get the total flux. But surface integrals are not there in your syllabus. Then, how do you go about with this? Consider a cube here. Charge Q at the center. Total flux will be Q by epsilon naught. Flux through PQRS is equal to Q by 6 epsilon naught. Flux through PQRS will be Q by 6 epsilon naught. Why? Through each phase it will be 1/6 of that. Now I could solve it this way only because the charge is at the center. I could solve it this way only because the charge is at. If the charge was not at the center, I can tell you first statement is right. Second statement will not be right. Based on this, they have designed one more question. What if the charge Q is at this corner? Name them 0, 1, 2, 3, 4, 5, 6, 7. What if the charge is at that particular corner? Now have a look at it. Flux. That corner is shared by 8 cubes. That corner is shared by 8 cubes. Have a look at it. I am speaking about this corner. For this cube, this corner, now I can place 4 on this platform, 4 on the above platform. This corner will be shared by 8 cubes. Are you able to visualize this? Here. Hold this. Bend it. Right? You're holding those two. Pull this two. I am speaking about, pull your hand back. Pull this hand back. I am speaking about this corner, 4 on this platform, 4 on the above platform. This corner is shared by 8 cubes. Are you able to visualize that? Now, this corner, if it is shared by 8 cubes, what part of it is shared by this? Flux through the cube will be equal to Q by 8 by epsilon naught. Now your point is flux through 0, 1, 2, 3, flux through 0, 1, 5, 4, flux through 0, 4, 7, 3 will be 0. 0, 1, 2, 3, 0, 1, 5, 4, 0, 4, 7, 3 will be 0 because the electric lines of ports from here will go parallel to the upper phase, parallel to this phase and parallel to this phase. The balance will be shared equally between the other three. Flux through 1562, flux through 2673, flux through 4567 will be equal to Q by 24 epsilon naught. Right, 1/3 of this. If you are seeing one corner, the lines of force from that will go parallel to this phase and that phase. And lines of force will be equally distributed between these three phases. Right? Understood the logic? Integrating and surface integrals are beyond your scope. Hence you will always have to use indirect means of Gauss law to get such type of problems. Quick. This is our radius. This will be the solid angle. Solid angle is area divided by
last
area.
half an hour. And see me down.
Yeah, but I don't think I'll be able to take that. I'll have to complete this. The subtopic I'll not be able to leave it in between. Right?
Okay.
Yeah, now this area will be S divided by R square will be the solid angle. Right? If I can calculate that area, I'll get the relation between theta and the solid angle. How do I get that particular area? I'll consider an elemental strip. This is alpha, this is d alpha, this is r d alpha. Right? So I'll remove this part of it. ds will be area of this strip. What will be the radius of this strip? R sin alpha. 2 pi r sin alpha will be the length. That into r d alpha thickness will give me the area. Integral ds will be s 2 pi r square integral sin alpha d alpha. Least value of alpha is 0. Maximum value of alpha is theta. Agreed? S is equal to 2 pi r square integral sin alpha minus of cos theta minus cos 0. S by r square is the solid angle 2 pi into 1 minus cos theta. Relation between solid angle and linear angle. If you take a complete sphere, what will theta be? Pi. If I take a complete sphere, theta will be pi. Cos pi. 1 minus of minus 1. 2 into 2. 4 pi is the solid angle subtended by a sphere at the center. Why do you need this? We need to solve two typical problems based on this concept. Take it down, I'll explain. Now listen. Once you have this relation with you, this is the way Iridov is asking you this question. He says, if you have got Q and minus Q, this is a disk, this is Q, this is minus Q at the same distance. Radius of this is A, this is X and X. They are asking you for the flux through this disk. They are asking you for the flux through this disk. Traditionally, what are you expected to do? You have Q here. Consider an element here. This is E and this is ds. Integrate that all throughout the ring. I will get the flux through that ring. That I integrate from here till here, I will get the flux through the disk. This is what traditionally you are expected to do. But then Gauss law and flux will come to our rescue. Have a look at it. If I connect these two this way and draw a dome shaped structure like this, keeping this as the radius. Now flux through this disc and flux through this dome shaped structure will be the same. Agreed? The radius of this will be under root a square plus cos theta will be x divided by under root a square plus x square. Why do you need cos theta? Listen. For 4 pi solid angle, the flux will be q by epsilon naught. For this solid angle, 2 pi into 1 minus cos theta, the flux will be q by 4 pi epsilon naught 2 pi into 1 minus cos theta. The flux through this dome shaped structure and through this disc will be the same. For 4 pi solid angle, q by epsilon naught. Who told us this? Gauss. Right? For 4 pi solid angle, this is the flux. For this solid angle, what is the value of this solid angle? 2 pi into 1 minus cos theta. This will be this by this into this. Cancel this out. This is q by 2 epsilon naught 2 sine square. Why do I do that? Put it in terms of cos theta. 1 minus x by under root a square plus x square. This will be the flux through this particular disk because of this charge. Because of minus q, I will have to multiply this with 2. Because of minus q, I will have to multiply this with 2. Why will you multiply this with 2? Listen to the logic. If I have q and q here, the lines of force will go this way. Am I right? So if I have a disk here, what will be the flux? 0 because of q and q. If I have q and q on these two sides, the flux through the disk passing through the equatorial plane will be 0. So now I add q here and q here, because if I add q and q, I will not be disturbing the question. I add q here and q here. If I have q and q here, what will be the flux through the disk here? Louder! 0. So can I add q here and q here? Yes. That will not change my problem. Q and minus q will become 0. Here I have q. I will multiply the flux with 2. Awesome. 2. Clear? Lightning speed.
4 pi
If this whole sphere subtends closed surface, 4 pi will be the angle at this particular point. Right? For 4 pi solid angle, it's like telling you for 4 pi the flux will be q by epsilon naught. For this solid angle, what will be the flux? Now listen, you have a charge q1 here, minus q2 here. A line of force from q1 will go into q2. This angle is alpha, this angle is beta. This angle is alpha, this angle is beta. Right? Krutov is asking you the relation between alpha and beta. Find the relation between alpha and beta. Find the relation between alpha and beta. Listen, the key catch in this concept is any line emitting in between these two cannot vaporize into air in between, nor can it cut it out of this. If it cuts out, then there will be intersection of lines. So any line in between will have to go into this. So total flux generated between these two lines should be equal to the total flux entering between these two lines. How do I get the total flux here? For 4 pi solid angle it will q1 by epsilon naught. For 2 pi into 1 minus cos alpha, this will be q1 by 4 pi epsilon naught 2 pi into 1 minus cos alpha. This will be q1 by 2 epsilon naught 2 sine square alpha by 2. This will be the flux between these two lines, because this will be the solid angle. Right? Half of that is my requirement. What will be the flux entering into this particular solid angle? For 4 pi solid angle it will be q2 by epsilon naught. 2 pi into 1 minus cos beta, it will be Q2 by 4 pi epsilon naught 2 pi into 1 minus cos beta. This will be Q2 by 2 epsilon naught 2 sine square beta by 2. Half of that will be the flux between these two lines. Half of this will be the flux between these two lines. Equate both. Is that clear? All of you? Today we have introduced Gauss law. Don't jump to conclusions and start trying the problems from Gauss law. Right? Today actually in the first half an hour we should have taken the doubts. Never mind, no issue. Our electrostatics start from Gauss law. Taking doubts from the first chapter of HCV will be done in 10-15 minutes. Next class we will do that and go ahead with shielding concept. Shielding concept is very important. The class will be the main reference for you. Please attend the class both mentally and physically.